Yeah, so thank you. This is work with Ofer, Arieli, and Strasser, and the idea was basically to see how certain design choices of your argumentation setting affect the properties that are satisfied by the argumentation setting, and in particular, argumentative entailments. So what we did is a characterization of the extensions based on the framework's components, and then accordingly identified the induced entailments. And we provide a classification of entailments based on how they handle revised information, so non-monotonic reasoning principles, and basically and contradictory data, so how the entailments handle inconsistency. For this, we looked at logical argumentation, and in particular, we represent our arguments by sequence, which are of the form gamma arrow delta, which are sets of formulas basically, and an argument is then a sequence where the consequent is just one formula, and the formula has to follow or has to be entailed by the support set. Now, unlike other or most other work on logical argumentation, we make a distinction between a set of assumptions and a set of facts. And an argument based on these assumptions and facts is then an argument where the support set, so in this case, gamma, is a subset of these assumptions and facts. Now, arguments are constructed based on inference rules, and the attacks are based on sequence elimination rules, where we have an attacking argument, the first condition, an attacked argument, the last condition, and conditions in between that determine how the attack takes place, and as the consequence of the rule, the attacked or eliminated argument. Well, for the inference rules, we take a core calculus with which all the proofs were provided. These are basically rules for the Tarskian conditions, so reflexivity, transitivity, and monotonicity, and we require a negation and a conjunction connective. Then for the elimination rules, we consider three kinds, namely, for example, undercut, which attacks in the support set, and this might not be just one assumption, but a set of assumptions. So in this case, gamma 2, which is a subset of the attacked argument. Or we consider direct attacks, which is an attack on one specific assumption. And we consider consistency attacks, which make sure that arguments that have a consistent support can also be attacked. So as a result, we have three settings: set attacks, direct attacks, and consistency attacks, which in addition to the direct attacks also contain the consistency attacks. Now, we have heard already quite a lot about semantics. We only consider a few. Namely complete, grounded, preferred, stable, semi-stable, stage, ideal, and eager semantics. And what we found is it's important to consider whether you want semantics that can result in several extensions, like preferred, stable, semi-stable, or stage, or in a unique extension, like grounded, ideal, and eager, since these semantics result in the same extensions. So as a result, we group them together in three possible settings, namely complete semantics, which contains all the completeness-based semantics, multi-extension semantics, which contains preferred, stable, semi-stable, and stage, and sometimes also complete, and single extension semantics, which contains the grounded, ideal, and eager semantics, and sometimes also complete. Well, therefrom we can define the entailment relations, which is this paper is all about. So psi is credulously entailed if there is some extension that contains one argument for psi. Psi is weakly skeptically entailed if in each extension there is at least some argument with conclusion psi, and psi is skeptically entailed if there is some argument for psi that is part of every extension. Well, this is our setting, and we consider three types of studies, properties. First, the connection with maximally consistent subset. Well, like in the argumentation setting, there are again three entailment relations, namely skeptical entailments, where phi has to follow from the intersection of the maximally consistent subset, weakly skeptical entailment, where phi has to follow from each maximally consistent subset, and credulous entailment, where phi has to follow from some maximally consistent subset. And what we found is that for direct and consistency attacks with multi-extension semantics, the extensions coincide with the arguments that can be derived from maximally consistent subsets. And for set attacks with single extensions, this is also the case. And then there are some more subtle conclusions that I encourage you to come and look at the poster. Then we considered principles for non-monotonic reasoning. These have been around quite for a long time, but we didn't study them before for logical argumentation, and especially in our general setting with the distinction between facts and assumptions. Well, these properties can be seen as maybe a bit weaker than, for example, monotonicity, because they can, the entailments are non-monotonic, but how non-monotonic are they? For example, we consider cautious monotonicity, rational monotonicity. There are weaker variants of transitivity, but we don't consider each of these separately, but in three groups, namely cumulative, where that contains cautious reflexivity, right weakening, left logical equivalence, cautious monotony, and cautious cut. Then preferential entailment relations that are cumulative and satisfy OR, and rational entailment relations that are preferential and satisfy rational monotonicity. Now, these are our results. And I think it's interesting to see that, especially for single extension semantics, more properties are satisfied, but only for multi-extension semantics with credulous entailment, the entailment is monotonic, as can be seen here at the bottom. Then the last set of principles are about inconsistency handling, and this is mainly about how inconsistent information is handled and if it's explosive or not. So, for example, for power consistency, if we have two atoms and we have P and not P, then a non-related atom Q cannot be derived. And then there are the properties that are known from the argumentation literature as non-interference and crash resistance, which we also studied here. And these are our results. And unlike in the case of non-monotonic reasoning, actually in this case, the multi-extension semantics satisfy more properties and actually satisfy all of them for all possible entailments. So what we did is we added the possibility of having facts in our logical argumentation setting. And we showed that it comes down to three choices when we want to design argumentation frameworks and want to know what properties they satisfy. The semantics, do we choose a single extension semantics or multiple extension semantics? The entailment, the elimination, sorry. Do we allow for attacks that attack just one assumption, or do we have attacks that attack arguments in a set of the assumptions? And how do we select the conclusions? Do we do this credulously, allowing for quite a few conclusions, or skeptically? And these are then the results that we obtained. Like I said, there is a strong connection between argumentation and maximally consistent subsets, especially for direct attacks, consistency attacks together with multi-extension semantics, or with set attacks and single extension semantics, and some more subtle results. If it's about inconsistency handling, multi-extension semantics perform better than single extension semantics. If it's about non-monotonic reasoning, actually the single extension semantics together with the direct attacks are the ones that perform best. But only multi-extension semantics together with credulous reasoning is monotonic. Now, I think this paper was quite hard to present because there are quite a lot of results, quite a lot of tables. So please visit our poster because I think it's better to show there what we did actually. Thank you.